In the government's latest response,
you must stay at home.
Master of the house, doling out the charm.
It's very important that everyone
know that you are not alone.
G'day chemists, in this video we are going to look at the nomenclature or naming of carboxylic acids. These are our organic acids and it might be my favourite group of organic compounds. I really like them, they're lots of fun. Like for example, the strongest, no not strongest, it's a weak acid, but the acid with the lowest recorded pH is an organic acid. It's a stupid long name and it's got a pH in the negative millions. I think it's like 32 million or something like that. That's a lot, right? Like that's a big, intense acid, organic acid. I really like organic acids. So yeah, that's what we're looking at today and how to name them. So our learning goal is to be able to identify the functional group, which is a carboxylic acid or carboxyl groups, and be able to name and draw carboxylic acids. I'll draw your attention to this over here, and you'll see that the carboxy group or carboxyl group gives us our highest priority. So if there's a carboxylic acid, doesn't matter what else is on there. If you see this carboxyl group, it's a carboxylic acid. That's how it will be named. Everything else is secondary. So this is our vocabulary for the lesson. Pause the video, hit like and subscribe, and write down everything that's here. It'll give you something to refer back to as we move through some of the new terms during the lesson. So this is our functional group, and we see that we have, it's called a carboxyl group, and the carboxyl group has a carbonyl and a hydroxyl. So it's a combination of those two words. So it's an R hanging off a C with a carbonyl and a hydroxyl. This means it's always the terminal carbon. So your carboxylic acid, at least one of them, if there's multiple carboxylic acids, like, citric acid has more than one, then, for example, at least one will always be numbered. At least the carboxylic acid, at least one of them will always be number one. Okay, so our general formula is CnH2n plus 1 with COOH at the end. And that's how it's written. So, let's have a look at how we name them. First is we identify the highest order functional group. In this case, it's the RCOOH. This is what it looks like in regular, expanded structural form. This is what it looks like in skeletal form, so the cool form. And this gives us the suffix oic acid. That's kind of cool. And it's called a carboxyl group. But the oic acid, that's what's put on the end. We identify the longest parent chain that contains that carboxyl group. We want to make sure it snakes around and collects the most possible double bonds or triple bonds, etc. and has the longest chain possible with all of that combined. And that gives us the prefix, usually from anywhere from like meth to dec to beyond that. But for our cases, it's rarely going to go above dec. We number the parent chain in the direction that gives the lowest number to the highest priority, which in this case is the carboxyl group. So the carboxyl group is going to be numbered 1 every single time. We identify any double triple bonds. That gives us our infix. So an, ene, ine. We identify and add prefixes to any components which have been identified. The di if there's 2, tri, so forth. We place any positional numbers. So numbers and letters are separated by hyphens. Numbers are separated by commas, and we'll see examples of this. All right, so here are our examples. First one, we identify the oic acid, like the carboxyl group. We number it. It's 4 carbons long, so it's butane. It's only single bonds. Butane oic acid. Butane 1 oic acid. Now, with all of these, I've written them as whatever 1 oic acid. You don't actually have to do that. If you're in my classes or whatever, we will do that. It's just good practice to do it all the time. And it'll stop you from not doing it when you do need to with other functional groups. So we want to avoid that. We go down the bottom here, this little carboxyl group here. The reason you'll notice that this one here is 1, 2, 3, 4 butane 1-oic acid. I just wanted to include one there as an expanded structural formula, not just as the skeletal formulas. Here we have a compressed structural formula. We identified our carboxyl group, again carbonyl, hydroxyl, and we can number them 1, 2, 3 propane. So that becomes propanoic acid. Then on the next one, we identify our carboxyl group. 1, 2, 3, 4, 5. So that's going to be pentane. But there's a sweet little methyl group there. And that's on the second carbon, so it's 2-methyl. So it becomes 2-methylpentane 1-oic acid. And that 2-methylpentane 1-oic is all one word. Remember that? No spaces. The next one gets a little spicy. We identify our carboxyl group. Number it, 1, 2, 3. And then, because this throws people a little bit, we've identified a halogen group, a halo group. And it's chloro. And it's on the third carbon. So it's 3-chloro. So we put all that together and we get 3-chloropropane 1-oic acid. If you have any questions, that's all the lesson is. If you have any questions, put them in the comments below and we'll get back to you as quick as possible. Thank you for watching. Please subscribe and keep up with what we're doing. And yeah, we'll see you next time. Bye now.